Today we are going to study what is recursion. What is recursion? How to define a recursive function and then how to solve a problem using what? Recursion. This is what we are going to study. First is we'll see what is recursion. In programming, what is recursion? A body operates on itself is called as what? Recursion. What is a recursive algorithm is? Writing a solution to a problem using the problem itself. Writing a solution to a problem using the problem itself. It's called as what? Recursive algorithm. What is recursive function? Calling a function itself is called recursive function. Calling a function itself. You're calling the function. Same function you're calling again. Calling the function itself is called as what? Recursive function. Now, when I can define a recursive function is, I must know the recursive algorithm. Okay, I must know the recursive what? Algorithm first. Okay. So, what do you mean by this statement? A recursive algorithm means. See here, right now, I want to find a factorial of 5. What is factorial of 5? 5 into 4 into 3 into 2 into is called as what? Factorial of 5. What is factorial of 4? 4 into 3 into 2 into 1. That means 5 into, I can say 4 factorial. So the whole thing can be written as 4 factorial. Therefore, what is 5 factorial is? 5 factorial is a problem. The problem I have is right now is 5 factorial. But what is the solution I have is, the solution is 5 into 4 factorial. I am writing a solution to a problem using the problem itself. But remember, not the same problem but different problem. Not the same input but the different input. Writing a solution to a problem using the problem itself. What is a problem? Factorial. Finding a factorial. Writing a solution to a problem using the problem itself, but not with the same input, with a different input. What is 4 factorial? That means I can write 4 into 3 factorial. What is 3 factorial? 3 into 2 factorial. What is 2 factorial? 2 into 1 factorial. What is 1 factorial? 1 into 0 factorial. What is 0 factorial? You can't say it is 0 into minus 1 factorial. 0 factorial is nothing but 1. That means there is a place you are going to stop it. Stopping point in recursive algorithm is called as base component. Base what? Component. Now, if you don't have a base component, what will happen? It will become infinite recursion. Why? If you see 0 factorial 0 into minus 1 factorial, it will become infinite. It will keep on going. Whenever you are writing a recursive algorithm will have two parts. One is a base component, other one is a recursive component. The recursive component will keep on calling the function till it reaches the base component. Once it reaches the base component, it stops the recursion. It stops the recursion. Now what happened after it stops the recursion? What is going to happen? Now look at this. You said 0 factorial is 1. So 1 into 1 is how much what? 1. Correct? The 1 will be substituted. Where it will be substituted? In the place of 1 factorial. Not in the place of 4 factorial. There is a 1 factorial. 2 into 1 is how much what? 2. 2 will be substituted here. 3 into 2 is what? 6. 6 will be substituted in the place of what? 3 factorial. 4 into 6 is what? 24. 5 into 24 is what? 120. That means once you reach the base component, you'll keep on going backwards. See, you will keep on calling the function till it reach here. Once you reach the base component, you'll keep on going backwards till you reach the first call. That means the call that is being made first will get the result last. The call that is being made first will get the result what? Last. The call that is being made last will get the result first. Then we'll keep on going backward. It is called last in, first out. Last in what? First. Let us see here right now. I want to write in another recursive algorithm. Okay. Let's say in this case, I want to find the power of a number. Let's say 2 raised to 5. What is 2 raised to 5? 2 needs to be multiplied. 2 needs to be multiplied 5 times. That means 2 raised to 5 can be written as 2 into, this is, what is this? This is 2 raised to 4. I am writing a solution to a problem using the problem itself, but not with the same input, but with a different input. So 2 into 2 raised to 4. What is 2 raised to 4 would be? 2 into 2 raised to 3. What is 2 raised to 3 would be? 2 into 2 raised. What is 2 raised to 2 would be? 2 into 2 raised to 1. What is 2 raised to 1 would be? 2 into 2 raised to 0. What is 2 raised to 0 is nothing but 1, my base component. Because once you reach the base component, you will give a direct value. The direct value 2 into 1 is 2, you will substitute here. 2 into 2 is 4, you will put here. 2 into 4 is 8, you will put here. 2 into 8 is what? 16, you will put here. 2 into 16 is what? 32. Base component. That means now we are going to define what is a recursion. Is writing a solution to a problem using the problem itself, but not with the same input, but with a different input. Every recursive function must have a two component. One is a base component, other one is a recursive component. The base component will always return a direct value. The recursive component will always call the function again with different input. Now in this case and the previous case, it was reducing, the power was reducing. Why? Because my base component is, what is the least possible input I can give to 2 raised to something is 0. The least possible input is on the lower side. Therefore, I decided to reduce it, keep on reducing. If the least possible input can be a higher value, then what I'll do, I'll increase and bring it. That means what you need to know here, see, even in factorial, what is the least possible input I can give to a factorial function is 0. That's why what I did was I was keep on reducing the value. Got it? So remember, so if you like my session, kindly share, subscribe and like. Writing a solution to a problem using the problem itself, but not with the same input, but with a different input. The difference will be, it can reduce or it can increase. It depends on your base component. The base component is on the lower side, you decrease and bring. If a base component is on the higher side, increase and bring. Okay, now the next is, once you reach the base component, you will keep on going backwards. You will keep on going what? Backwards. Okay. If I want to convert this into a program, how do I convert? Okay. I want to I'm going to define a function. Now I'm going to define a factorial function. Integer n. Integer. Okay, I'm writing here f is equal to 1. See, I'm writing a loop. I is equal to 1. I is less than or equal to n. I plus plus we wrote it. F is equal to f in, right? Equal to f into I. And return. Correct? So this is, you never wrote a recursive function here. This is called an iterative function. You are using a loop. Okay. If you are using a loop, it is not a recursive. Okay, it's not a recursive. A recursion and iteration are parallel. Both what does the same work. Can I use a loop inside a recursive function? Right now, I would say no. There are cases you are going to use. Those concepts will be called as different. It's called backtracking. Right now, no. None of your function which you are going to solve is going to use what in loop here. Recursive function is not going to use what a loop. Okay, but I'm going to show you how it's similar. Okay. So you write here right now like this. F n is equal to 5, which is f is equal to fact of n, print f to fact percentage t, what? And the code, order. Correct? Yeah. Now this is not a recursion, boss, this is an iteration. In recursion, the first thing is you need to write. Remember, whenever you write a recursive function, you must have two components. One is a base component, other is a recursive component. What is the least possible input I can give to the function? If n is equal to 0, return 1. If n is 0, factorial of 0 is 1. If not, what is 5 factorial we said? 5 factorial is nothing but 5 into 4 factorial. That means n factorial is nothing but n into factorial of n minus 1. See, the 5 factorial you write like this, correct? 4 factorial, how do you write? N minus 5 into factorial of 5 minus 1 is 4, if n is 5. That value needs to be returned. That value needs to be what? Returned, okay? I say in this case, z is equal to, I just properly store it, okay? I could have directly return also. Return, got it? Now let us see here in this case, I want to run the same thing. I'm going to run it. Same one put on. So 5 into 4 factorial we wrote right now. That is, I'm writing this if n is 5. Okay. Now look at this right now. I want you to understand little better of this. Okay. How it is recursion actually what works. Okay. If you want to understand, you need to, we will do some research. Okay. First is here in this. Sir, instead of n minus 1, okay, can I write n minus minus? You can't. Why you can't? I'm going to show you. Let's put some output and get the output first, how it works. Okay. See, okay. Now I'm going to print the n value here. Okay. Percentage d. Okay, put for you p, comma what? Okay. And then here also I'm going to put. Once you say return, nothing will happen, right? You know it. Therefore, I'm going to put a print of here also. Just for you to understand what better. Let us see how the output is going to come. Okay, now before we run the code, let us analyze it and then how the recursion works. Then we will solve. Okay, we'll run the code and see. So let us see how this gave you the answer 120. Okay, and what are the learnings you are going to make? Observe carefully. Okay, now see here I have written two functions. One is a fact. Other one is what? Where the execution will begin. The execution will begin with main. You can have any number of functions. Any number of what? Functions you can have. But where execution will start with main. If you don't have a main, the execution will not begin. From the main, all the other functions will be called. Okay. Or through the main, all the other functions will be called here. Okay. Now, see here now, n is 5. Now I put fact, I call the function. Right now, I am executing a function called main. But now I am calling a function called fact. By this, what is going to happen? What is going to what? Happen to? Okay. What the system does at a time, it can execute only one function. It can't execute more than one function. What the system does, it creates a stack. It creates a container to store the information of main. What are the information? Where I started, where I ended, where is it right now? What are the variables are there? What is their values? What is their addresses? All the informations are preserved. After preserving, what it does, it goes to this function. It goes to the fact. How it goes means it pulls this function from the RAM to the processor for execution. Now when it goes, this function now, this function is being brought to the memory now. That main is not existing. Therefore, the main and fact can have a same variable name. Doesn't matter because they are two different. Once you call this function, once you call the fact, main will go inside the container, stack will go, it will be preserved. Now, when the function is called, the control gives to this function two type of information about fact main. One is the n value. Other one is where the stack is stored, the information is given to the fact. Okay, the stack, where the stack memory is stored. Now I call, what is my n value was? My n value was 5 I called a function with n is 5. From where I came from main. Remember, the stack information of main is given to this. Now it is a recursion, correct? What is going to happen? It prints A, and what is the n value is what? 5 is printed. Then n is 0. No. Okay, now n is not 0, n is 5, right? Therefore, in order to complete this function, the system needs to execute 4 statements. In order to execute this function, it has to execute what? 4 statements. First statement executes B and n is 5. Look at this, a 5. Now again I went, again I went to what? Again I go second statement. What is my second statement? N into fact of n minus 1. It creates a new variable called z, and there is going to store n into fact of n minus 1. N is 5. 5 minus 1 is 4. It is making a call for fact of. That means now who is calling? The 5 is calling with what information? N is what? 4. This is my N. This is my stack. 5 is calling with the information what? With the N what? 4. Because N is 5. 5 minus 1 is 4. Right? I call for 4. That means these two statements have not been solved so far. 4. Right? I went for 4. When I went for 4, how many statements I need to execute what? 4 statements. Why? First is print A and 4 is done. N is 0. No. I need to execute 4 statements. First statement B and 4. Why? Because here my N is what? 4. Then I said fact of N into fact of N minus 1. 4 into fact of 3. That means 4 is a stack, 4 ka stack, and what is being passed N is what? 3. Right? I called. It printed what? A and 3. 3 is equal to 0. Condition is what? False. I execute 4 statements. Before executing 4 statement, I execute B and 3 is printed. Then I execute the next statement. What is the next statement? 3 into fact of 2. 3 into fact of 2. Okay. I call for fact of 2 now. Who is calling? 3 is calling with N value what? 2 it is passed. So first statement what will be printed? A and 2. N is 0. Condition is false. I went to the else part. I need to execute what? 4 statements. First statement. What is the first statement? B and 2. I went to the next. What is the next? 2 and what? 1 I call. Why? Because 2 into factorial of 1. Now I said 2 and 1. I passed here A and 1. I need to execute 4 statements. Why I came to the else part? First statement. What's the first statement? B and 1. N into fact of N minus 1. N is what? 2 into fact of 2 into fact of 2. Sorry, I wrote here by mistake. Yeah, I called this function 2. Yeah. 2, 1 and pass. Right. So 2 into fact of 0. I call fact of what? 0. I passed here right now. I passed here 1 and 0 I passed. 1 is a stack, 0 is a... Again I went. 0, I passed 0. I printed A and 0. Then I printed N is 0. Condition is true. If this condition is true, only one statement needs to be executed. What is the statement? Return 1. Return 1. Where I will return the 1? Where my stack is right now? Here. I am going to return the 1. I am going to return the 1. I am going to change the color for you to understand. Return the 1 here. Now, this is over. Now, next statement. What is the next statement? Is C and N. C and N. What is N is? N is here. N is what? 1. Look. Now I say last statement. Return Z. What is a Z? 2 into 1 is 2. Is being returned. Sorry, 2 into 1. No, so here I made a mistake, guys. This is 1. 1 into 1 is 1. 1 will be returned here. Sorry. Now I go. Next statement here. What is the next statement? If 2 into 1 is 2 is being calculated here. Now I say next statement. What is the next statement? C and 2. This is my N value. Now I say 2 into 1 is 2. 2 is going to be returned. To whom it is going to be returned? Stack 3. 3 into 2 is 6. 6 B C and N. What is the N value is what? Return 6. 6 will go here, right? 4 into 6 is what? 24. C and 4. 4 into 6 is 24 will be returned to whom? Yeah. What is my N was? 5. 5 into 24 is what? 120. C and 5. After C and 5, what is going to happen? Return 120. Where is going to return the 120? To the main. And here this is going to come. Here it's going to be stored. Now look at this. Now what is going to happen for me? If you look at this, the first thing you need to see, every call, I called the fact function 6 times. Every call created a new set of N, new set of Z. Therefore, every call creates a new set of variables. Those set of variables is available only for that call. It is not available for the others. Okay. Therefore, the N of 5, the N of this can't be accessed here. They are two different. Therefore, the first principle you need to understand, every call will get a new set of local variables. They have nothing to do with the previous set. Okay. Now you look at this. Now it was coming 5, 5, 5, 5, 4, 3, 2, 1 and 0. Then it become what? 1, 2, 3. After 0, it become 1, 2, 3. Why? Because till you reach your base component, what was happening, you will keep on going downward. But once you reach your base component, once it returns a base component value to this, you keep on reversing backwards. You keep on reversing what? Backwards till you go to the first call. Okay, let us run and see first whether the same output. You can mark the output and see is A5, A4. Okay, so this is the start number. Who made a call? Who made the call and what was the n value here? Okay, one place I just missed out. Okay, make sure that you understand. Now let us see. I'm going to enter code, see what is happening. I got the output. Let's see A5, B5, 4, 3, 2, 2, 1, 0, then 1, 2, 3, 4, 5. Because once you reach a base component, then we'll keep on going backwards. When you reach the base component, after reaching the base component, we'll go to the next statement of that. Okay, remember that C was executed, therefore it will keep on increasing. Okay, keep this in mind. Okay, now tell me, if I could have put here in this case n minus minus, what will happen? What is going to happen if you put n minus minus? Let's go back to the board. If I put n minus minus, what would happen for me in this place if I put n minus? When I call the function, n minus minus is a post decrement, right? Therefore, what will happen for me? What you say, n into fact of n minus minus. That means you call the function 5 again. That means you'll pass here. What will pass? What? Not 4. What will pass? What? 5. After passing 5, your n will become 4. Okay. Sir, what about if I put here in this case minus minus n? Therefore, if I put 5 again, what will happen? It will become infinite recursion. Okay. What about if I put minus minus n? Yeah, it will work. But your challenge is here. See, n minus minus if we put, what is going to happen is it passes the 4 for the first call, then it also makes a n as 4. If it makes a n as 4, what will happen? When it came back to this place, if you print the C value, you won't get here 5, you will get 4. That means you won't get here 4 here, you will get what? 3. You won't get 3 here, you will get 2. 1. Here you will get what? 0. Okay? Therefore, never try to change the value of the argument in when you are calling the function. Okay, never change it. Okay, because you need it when you come back. Okay, if you want, I'll go and show you. Okay, I'll show you first. Now, what is that? I want to put what now? Right now, you got 1, 2, 3, 4, 5. Now, I'm making what? Minus minus. It's going to become, you will get 4, 0, 1, 2, 3, 4. Why? Because you reduced it. Therefore, ensure that do not change the value of the argument, because when you come back, you need them. You what need them in many cases. In this case, is not needed, okay? But in many cases, what needed, okay? Keep this in mind. What you need to do, for every call, a new set of local variables are made. They have nothing to do with the previous set, okay? Next is here, do not change the value of the argument within the function, because when you come back, you won't get them. You won't what? Get them. Okay. Let us convert that, the other one also into a code. What is the other one we wrote? We want to find the power of a number. Okay. So we have a 2 parameters, base and the power. What is changing? The power was changing. What is the least possible input? The power is 0. What I should give me? 1 right now. How I write it? Simple thing. I'm going to the compiler. I'm going to put here right now. So what we said, if n is what now? Let's say power, integer, base, integer power. You don't need it. Okay. What we said, what is the base component? If p is 0, What I should return? 1. Anything raised to 0 is what? 1. That's the least possible input. Okay. Otherwise, what we said? Otherwise, z is equal to the 2 into base into the power of, what I should write? 2 comma 4, right? If we pass in p is 7, 2 comma 6 it is. How to call the function? It is base comma power, base comma power, base is 2, power is what? 5. Add up the code, run the code. I get the answer. Sorry, here I wrote fact. I'm sorry. I wrote what? Power. Okay. 32. Got it? So first is, now you need to break down your problem, write down like that, and what is the base component, what is the recursive component, decide, then you make a decision on that. Yeah, okay.